So these are the problems from section 4.10 that people wanted to see. So the first problem is problem number 4. So problem number 4 asks for the limit as x approaches pi over 2 from the left of x minus pi over 2 secant of x. So if I try to just regularly plug in, we would end up with pi over 2 minus pi over 2 times the secant of pi over 2. So pi over 2 minus pi over 2 is 0. The secant of pi over 2, so remember at pi over 2, the secant graph has so here we are at pi over 2. So at pi over 2, the secant graph there's an asymptote, and if you remember, the secant graph looks like these U's, and so we are coming, that's where this from the left side is important. We're coming up to the secant graph from the left side here at pi over 2, and so what's ending up happening is we're going off towards positive infinity. So this ends up being that case 0 times infinity. And so when we have 0 times infinity, we have to do a little bit of algebra work. So this is going to end up being the limit as x approaches pi over 2 from the negative side. So this actually isn't too bad. If you remember, the secant of x is just 1 over cosine x. And so it kind of lends itself pretty naturally for us to rewrite it. So it becomes the limit as x approaches pi over 2 from the left of x minus pi over 2 all over the cosine of pi over 2. And so now if I look at this, if we plug in, we'd have pi over 2, not pi over 2 already on the bottom here, it's just a cosine x. Jumping the gun here. So we have pi over 2 if I plug in minus pi over 2, all divided by the cosine of pi over 2. And so this is going to end up being 0 over 0. And so now I can do L'Hopital's rule. So the limit x approaches pi over 2 from the left. The derivative of the top is 1. Derivative of cosine is sine x. And so if I plug in, I get 1 over the sine of pi over 2, so which is 1 over 1. So the whole entire limit ends up being, and I forgot, the derivative of cosine x is minus sine x, right? So minus sine x minus sine of pi over 2. 1 over minus 1, so the whole entire thing is minus 1. So the next problem you guys wanted to see was problem number 6. So in problem number 6, we have the limit as x approaches 1 from the right of 1 over x minus 1 minus 1 over the natural log of x. And so if I try to plug in, we'd end up with 1 over 1 minus 1 minus 1 over the natural log of 1. And so this would end up being 1 over 0 minus 1 over 0. And so that's how I ended up with infinity minus infinity, right? 1 divided by something that's approaching 0, so 1 divided by really, really tiny is going to be super big. So that's where I get the infinity minus infinity. So I want to be able to get it to use L'Hopital's. So that's where I want to make a common denominator and get it into one fraction. So in this case, we have the limit x approaches 1 from the right. So my common denominator is going to be x minus 1 times the natural log of x. Excuse me. So this first fraction was missing the natural log of x, so I'm going to multiply the top by the natural log of x. The second fraction was missing the x minus 1, so we'll take x minus 1 times 1. And so in this case, we end up with the limit as x approaches 1 from the right side of the natural log of x minus the quantity x minus 1 all over x minus 1 natural log of x. And so now if we plug in, we end up with the natural log of 1 minus 1 all over 1 minus 1 natural log of 1. So we end up with 0 minus 0 divided by 0 times 0, which is 0 over 0. So now I can use L'Hopital's rule. So we're going to take the derivative of the top. So it's going to be 1 over x minus the derivative of x minus 1 is 1. All divided by, so for the bottom we're going to have to use the product rule. So first times the derivative of the second plus the second times the derivative of the first. Derivative of first is just 1. And so if I plug in now, we end up with 1 over 1 minus 1 divided by 1 minus 1 times 1 over 1 plus the natural log of 1. And so again, we're going to end up with 0 on the top, 0 plus 0 on the bottom, so we're back at 0 over 0. So I have to do L'Hopital's rule again. So we get the limit as x approaches 1 from the right. So remember that 1 over x is really x to the negative 1. So when I take the derivative, it's going to be negative x to the negative 2 divided by, so down here on the bottom on this piece, I could use the product rule again, but it's a little bit easier if I were to distribute this. So this would be x over x minus 1 over x, or just 1 minus x to the negative 1. So this is going to end up being x to the negative 2, because the negative 1 comes down. Negative times the negative 1 would give me a positive 1, x to the power minus 1. So x to the negative 2 plus the derivative of the second, which is going to be 1 over x. So this is really, my line is way too long here. So this is really equal to the limit as x approaches 1 from the right of minus 1 over x squared, all divided by 1 over x squared plus 1 over x. And if I plug in 1, I get minus 1 over 1 squared divided by 1 over 1 squared plus 1 over 1. So we really just have minus 1 divided by 1 plus 1, or minus 1 half. And the last one that people want to see was number 7. So number 7 asks for the limit as x approaches 1 from the right of x to the 1 divided by 1 minus x. So again, if I plug in, we're going to have 1 to the 1 over 1 minus 1, which would be 1 to the 1 over 0, and we talked about how 1 over 0 goes to infinity. So we end up with 1 to the infinity. So this is one of those cases where we have to look at a different limit, which is going to help us untrap the power. So we're going to look at the limit as x approaches 1 from the right of the natural log of x to the 1 over 1 minus x. And that allows us to bring the power down. So this is going to be the limit as x approaches 1 from the right of 1 over 1 minus x times the natural log of x. So it's going to be the limit x approaches 1 from the right of the natural log of x over 1 minus x. If I plug in, we end up with the natural log of 1 divided by 1 minus 1, or 0 over 0. So we're going to do L'Hopital's rule. So we end up with the limit x approaches 1 from the right. The derivative of the natural log of x is 1 over x divided by 1, oops, not 1. Derivative of 1 is 0. The derivative of minus x is minus 1. So this all becomes 1 over 1 divided by negative 1. So it's all negative 1. But remember, our original problem didn't have that natural log in it. So I found that the limit when the natural log is in there is negative 1. So to undo the natural log, I have to take e to that power. So my original limit is the limit as x approaches 1 from the right of x to the 1 over 1 minus x is going to be e to the negative 1. So I take the answer that I got here and I do e to whatever power that is. And that is my final answer.